Good afternoon, friends. Before start of the lecture, we'll have the refreshment first, because once we start, we cannot go further. So we will finish off your refreshment and come back at the earliest. So maximum 5 minutes, please. Refreshments is waiting outside. Yeah.
And just putting the water there.
It will be there. Yes. Online development. இது கரெக்ட் தானே? ஸ்பீக்கர் ஆன் பண்ணிடுறீங்களா? Very pleasant good afternoon to Dr. Soman, colleagues of various departments, my dear student friends from all the departments of TNAU. Indeed, it's a nice day for us because in agriculture, water is a prime resource which are deteriorating day by day. We are facing a lot of problem in getting water. So today's endowment lecture, we have invited Dr. P. Soman. He's a global scientist. So he is with us. A brief word about Dr. Soman. He is a principal agronomist designated as a global scientist in Jain Irrigation System Limited in India, which is the largest drip irrigation company. Our guest speaker is a PhD from Reading University, UK, in crop water stress physiology. And he has been working with ICRISAT, International Crops Research Institute for Semi-Arid Tropics, as a principal scientist. He researched in India, West and Southern Africa. As a principal agronomist of Jain Irrigation with the global research, he is in charge for technology development and extension and training wing. He is involved in farmers training and capacity building in the all states of our country and the countries overseas. He takes lead in Jain's work on developing commercialization of high-tech crop production practices for a wide varieties of crops like rice, wheat, sugarcane, vegetable fruits. The list will go. Almost all the crops he tried in agriculture crops and horticulture crops. He is a voracious traveler. He traveled to all the continents, and to provide technical support for project implemented by Jain Irrigation. He has several scientific papers published in the International Agricultural Journal, and he is the author of 2 books. Since he is working for a global scientist, he has worked in West Africa, East Africa, and Southern African countries, and also in Brazil. He continues to provide technology support to projects. He has been supervising PhD scholars from different universities and institutions collaborated with the Jain irrigation system. So our guest speaker is having a vast knowledge in water economization, especially in the field of drip irrigation investigation system. We are lucky enough to have him today's for the endowment lecture arranged by the Department of Agronomy. I welcome you, sir, for this August function. Here, all the professors, there are all the PhD and scholars of various institutions. I welcome you on behalf of our our Vice Chancellor, indeed, interested to come over here and attend this function because of her preoccupation. She is unable to come. I think she might be joining in the online. Similarly, our Director of Crop Management, she also interested to come over here. She's also in other preoccupied. So otherwise, people are joined in the online, sir. So I welcome you all the people sitting in the online, offline, as well as the chief guest. Once again, I welcome you all. Now I hand over the mic to the chief guest for his lecture. Welcome, sir.
Before we get into the topic, we first take this opportunity to thank Professor Panneerselvam first, the respected Vice Chancellor of this university, Dr. Gita Lakshmi, Dr. Sendil, and Dr. Kalaran. She is the crop director of the crop management, and all the other faculty members and PG students and students who are assembled here, as well as who likely to be watching this program through the online mode. It's a great honor for me for several reasons. First, I should say TNAU is known as one of the best agriculture university, as I know of, in India. And when we travel, I keep traveling. When I travel over different countries, and I also visit the respective universities, like in Lalpur University, Texas. And when we get into discussion with people, they will mention only 2 or 3 Indian universities by name. And you can be proud of that. Tamil Nadu Agriculture University always mentioned. It is not to make you please, make you happy, I'm saying it's a fact. The interesting thing about it is that I'm not an agriculture graduate at all. My becoming an agriculture scientist, a lot to do with the United Kingdom and the rules there. I post-graduated from Kerala Pure Science University, Trivandrum, MSc in plant science, and I happen to have the record, mark, and gold medal, etc., etc. Then I actually went to Delhi University. I went to Calicut University first for starting PhD. My parents are from a lower middle class background. So there they discouraged me. I wanted to do work in rice breeding at that time. I mean, you don't know. I changed, a lot of things happen in your life. So that was the goal. Rice is a crop grown in Kerala, of course in Tamil Nadu a lot, and in Andhra Pradesh, southern India. But unfortunately for me, to do rice breeding. Then I went to Delhi University, for Sir H.Y. Mohan, B.K. Jori, and all that. These are names which are on. And they accepted me with a CSR fellowship. I started doing work. That's the time I got a call from Ministry of Education, Government of India. They have some way of finding out rank holders from universities and all that. And they gave me a fellowship, asked me, if you want, you can go overseas and do PhD. So I made use, my parents agreed, I made use of the situation and scholarship. Again, I was not getting any guidance. Where do I go? People say, go to USA or go to Australia. And this is, sometimes if you don't get proper guidance, you get into trouble. But for my not getting proper guidance was the best that happened to me. So I went to IARI and asked Dr. Sinha. He used to be the director of water technology. He's no more. Sir, I have got a fellowship. I'm in Delhi University now with a CSR fellowship. I got another fellowship. So he was very keen and interested. He said, you should work the latest in science in crop physiology and agronomy. That was, at that time, it was plant water relations, crop water relations, we say. And another professor from CSIR of Canberra. Has to be unimaginable for a 32-year-old man. So I went with him because he happened to reply, that's the rule, professor. He said, why do you want to work in Kerala? You come and work with me, you become at least a good agriculture scientist. And that's what I did. I went to him. He was an exceptional genius. He never guided me. Now, interestingly, this is the topic you are going to work. We discussed the topic. And because he's a diabetic, he's an acute diabetic person at that, even at that young age, he became Professor 32, but I'm meeting him around 38, 40s that time. He comes to office at 4:30 a.m. No other professor comes. He has a huge lab of his own. You know, there the professor is the owner of the lab. That's the way UK system works. Everybody has to respect him because he's a professor at a very young age. And he's known in the UK, well known in time. So our discussions used to, and he used to make me drink black coffee because he's a, so from that time onwards, I drink black coffee around 5:30, even now at home. And no sugar. I don't sugar too. But our discussions used to take place between 5:30, 6:30 or so. He is allowed to leave the university at 2 o'clock because for diabetics, the sugar level goes up after lunch. I'm sorry to say, I hope none of you are diabetics. I think my wife is, so I know that. So you have to be careful. They feel more drowsy, you can't attend to cases and all that. That gave me another opportunity, not that his illness. All his classes of graduate and postgraduate, I used to take it after 3 o'clock classes, 2 hours. So there are very good experience, very bad also. The British students used to, the Aryan, I don't use any other word, the Aryan British students used to ask me, oh, you have cockroaches and houseflies. I have a very good answer for that. I don't want to repeat that here. But that gave a lot of experience. And one other thing about UK is that you can go to any other professor. He told me in the first day itself. Any other professor, any specialist. If you have a doubt, you go, ask for an appointment. And without appointment, also students are free to meet them and discuss. So I became slowly a good crop physiologist. And my thesis is on crop physiology. At the same time, as an agronomist, I'm myself saying crop physiology, good. Please don't misunderstand me, according to the university. And agronomy, and now that's physiology, crop physiology. Then only he can work successfully with that. I came through the stream. And of course, after that, I joined ICRSAT as a scientist one, and then ended up having as a principal scientist. Anyway, why I said is that pure botany man. Now, I didn't work in any government system in India or in Kerala or anywhere. So when agriculture universities used to be a place where I always worshipped, because I cannot go to one, except the one I went to in the UK. And now, of course, no regrets. I'm 70. I have done, I think, reasonably well, as my professor used to say. This is just a background. I joined Jain Irrigation when they were looking for a person, only engineers. So far, there were only engineers there. Engineers means my deep and all the top people. But I realized that if you want to give drip irrigation system to and sprinkler irrigation to a farmer in India, he should be made understood how it works. They didn't have people for that. Engineer just explained the hydrology. Engineer explained the length of pipe. And I'm not saying that that is very important. But there is other side. Farmer is actually going to do a crop with this. For him, it's just like buying a tractor or a pair of bullets. That's the technology here. But somebody has to tell him, when you have these irrigation systems, you can do far better than what you are doing it. That's what I did all this time, and I'm still doing it. Now, drip irrigation, by the way, I had a basic experience while I was working in my PhD, as I have used some of these things which I talked about. A very critical point in drip irrigation application, actually. So many farmers, when they get a drip irrigation, somebody, maybe the distributor will say, okay, you run it for 2 hours. It's not like that, actually. 2 hours has nothing to do with it. Maybe for a crop like wheat, 2 hours will be excess. What I'm trying to say is crop dependent, location dependent because evaporation changes with the location, as well as age dependent, crop age dependent. So all these factors are coming in the way crop water requirement is estimated. And in addition to that, I had experience during my crop physiology agronomy research. I was looking at potassium, phosphate, iron, and how the ions help in drought adaptation and all that. So I started looking into that's just to give you a. Now, what I did in James is what I'm going to speak. When you have a drip irrigation given to a farmer, we all know that even before that, drip irrigation somehow gives some improvement of crop production, that is yield or sometimes quality and all that. How does it come into being? No one actually research. That's first thing I did. So we have, how do you like that one slide? You have a slide movement. Oh, okay. Okay, I'm just getting used to it. Sorry. Yeah, of course, there are a lot of. By the way, all the people who are working in agriculture is my belief, and I firmly believe in that. There's no other profession, even medical profession is secondary to that. Not because I'm not a medical doctor, I'm saying. You imagine all the people who are working in agriculture, including the farmers, disappear from this planet. Doctors will starve. You don't have health. Health is food, actually. So food is the first one. If the food cannot give you the health and deficiencies in health, then only medicine comes in there. People have a belief that the human society, the pillars are the people who practice agriculture, either as theory or as practice, and the farmers. Imagine the entire farming community is transported to moon. It may happen actually, to cultivate moon. Almost like in Mahabharata. The dry tracts were cultivated by the Pandavas because they got only very dry tracts. And Krishna helped him. They made it into Indraprastha. When they made it Indraprastha, they got envy and then the war and everything comes in there. People work with the soil. That's what happened there. So there you get the first pillar of the human existence, not only human, all animals, for example. Everything comes from agriculture. It's not like chicken. Chicken has to, somebody will say, hey, no, I don't eat any grain, I eat only chicken. But chicken has to eat grains to produce chicken and the meat. Okay, so it's basically agriculture. That's what the. Now, what is the problem in Indian agriculture? All of you know that I'm just getting you into the mode of thinking. We are highly, like any other country, probably like, unlike many other countries, highly climate restricted agriculture is what we are practicing. Almost 58%, about 52% of the land mass of India receives excess rain during the rainy season. And the rest, which is 42%, receives deficit rain. So we have a problem on both ends. That's why our agriculture is so a challenge. And it is a water-related challenge. So anything to do with the agriculture, we have to think about water and rainfall first. And of course, we cannot irrigate all our land with the rainfall for 12 months. Maybe possible in Malaysia. That's why they don't irrigate oil palm. It's a big story. Oil palm, when it was introduced in India, they thought that oil palm doesn't need irrigation. It's not like that. Almost every 2 weeks, there is a 50 millimeter rain falls in Malaysia. So they don't have to irrigate. But in India, it's not like that. After about 3-4 months, you have an extremely dry climate. All of us, wherever it is, whether in North India or in South India or East or West. So we have to have water management. We have this is our tragedy and the main challenge. I'm sorry, I'm getting a bit. The blue line is our available fresh water, 1143 billion cubic meter. It won't change. Many people say, I can create water. You can create an atom bomb, but you cannot create water. You cannot join H2 and O. Unfortunate, right? The other two lines, which what simply means is by 2050, and before that, we would be running out of water. All the water will be utilized. There's no excess water. That's what the country is actually creating, all types of projects and programs because of this fact. This is not my data. It is the Central Water Commission. I just plotted it. So that's the crux. Now, that is why these irrigation systems and irrigation methods, all that becomes important for the country to produce food, to feed. Now, India feeds not only Indians, India feeds several countries overseas. You may not have seen the news last week, it came in some media. A lot of people in Pakistan, I go there, but I have nothing to do with the political or anything. I go there often and work there too. A lot of people from the rural Pakistan are starving for atta. Atta is the wheat flour. That's the only thing they eat. They don't have it. And because of the pride and of the country, India used to supply. India is ready to supply also, but we cannot do it, political reasons and all these other things. People are starving. And when I had a personal experience, when I was taken in a car I usually go into rural areas to work with farmers. When a car was stopped at one place just because of traffic, a lady with the 2 or 3 children hanging came and asked. Of course, we'll get it on the railway station here. She didn't ask for money. In Hindi, she asked, "Thoda aata de dijiye." I mean, please give me some wheat flour for making food. This is the situation. And I felt very, very sad. I didn't have water with me. I had even my own food is depending on my host. There. It's a sad thing, actually. India is supporting that. Our grain production is so good that we can support a lot of countries, but because of the political difficulties, we cannot directly support them, actually. Which is a good news to say that from Indian side. Now let's talk about, you're all agronomist. If this statement I made is wrong, you can correct me. Because I'm practicing in agronomy, so I must know what agronomy is in Indian situation. Agronomy, of course, a branch of agriculture deals with the field crop protection. That's ultimate. And it involves management of soil, crop, and to some extent the environment. Some extent only. If there is no rain, we cannot manage rainfall. But we can manage the existing rain which has already received. That's the idea. And similarly, if the temperature is too high, we can manage it to some extent, but we cannot reduce it. Agronomic research focuses on a variety of factors affecting crop protection. Every factor you are researching in agronomy is actually directly dealing with the crop protection. The amount of grain or fruits or leaves or whatever you are getting. And of course, to do that, these factors are crop variety. Variety change. If you change a variety, you can change the yield. We have seen it. Geometry. This is one thing I stress a lot. Because many farmers are not properly advised to do. They follow some recommendations given by the government or by the public institutions on crop spacing. And many places, when we introduce, that's where the whole thinking process started with me. The crop spacing had to be changed. There's no sacrosanct about it. It's not like getting into the sanctum sanctorum of a temple. You can change the crop spacing. I'll show you that. Land and soil management, land surface management. How do you plow? Whether you do plain, flat cultivation, or you do bed and furrow, ridge and furrow, different types of things. And soil management, of course, basically soil carbon, enriching carbon, and then the other thing. Pest and weed management, which also is part of agronomy. And sensitivity to these factors, such as climate and soil. And ultimately, it all leads to yield or productivity and quality of produce. Sometimes with the poor management of soil, you can get fruits, but the fruits may not be good tasting. That's why you always say, Alfonso coming from Goa and around Ratnagiri is the best. Alfonso coming, I don't believe it, but Alfonso coming from Chittoor and northern districts of Tamil Nadu are not equivalent. But that's actually a wrong thinking because they never looked at the real quality of Alfonso there. Agronomists also utilize ecological principle to conserve. That's what is required for the against climate change as well as conservation agriculture and protect the environment from the negative effects of agriculture. Why I went to detail into that is that some of the things which I'm going to do on crop-wise, basically this is the background. Now, this is the way the technology of irrigation developed. We started with the water. Now we have the flooding. These are the flood irrigation. It's different from the furrow. Furrow means some order is established. In flooding, there is no order. You break the bund, water gets in. Water gets into, according to the slope of the land, it reaches where the lower slope is. In furrow, of course, you create a slope, certain, that's what they do with the laser leveling, etc. Many of you would have heard or experienced it. And then you have sprinkler irrigation technology first, which they say it is equivalent to rainfall, which is not true. And then you have drip irrigation, where you have drip tubes kept on and then wetting, very limited wetting, only the rhizosphere. And of course, then you put the tubes below the ground, you get subsurface drip irrigation. All these things we practice. As at present, things may change in the future. As at present, in the world, drip irrigation is the most water conserving technology available. That's maybe next generation or somebody will come with something else. We don't know. See, when we were practicing flood irrigation, we never knew that. After 35 years, there will be drip irrigation like that. So there will be something else. So that's what Now, what is the drip irrigation? I'm not talking about the design factors or the material. It's actually a calibrated application of water. That's the first thing. Calibrated means after studying or estimating the requirement of the crop on a daily basis, give that much water. That's what the calibration means there. Water and nutrients also can be given, later we understood. And that's called fertigation. And through special polymer tubes, you see the drip line, drippers or emitters. And the water is always emitted near the root zone, very important. So the water is not actually going into the dark soil areas. Water and fertilizer and micronutrients are applied at equal intervals as per the physiological requirement of. That's very important. That's why I put it in red. Even water and the fertilizer we give is not like a 3 times fertilizer for banana, 4 times fertilizer for vegetables. It's not like that at all. There is a time when, just like we eat when we are hungry, plants, we could understand when the crop will be ready for a fertilizer. Originally, when this fertigation was introduced, I'm not talking again about the equipment. The equipments, we can forget it. Originally, people thought that it is just to divide the fertilizer, NPK, whatever you give. If you are giving 4, make it to 10 times or 20 times. That is not fertigation. Fertigation is actually identify the need of an element by the crop at each stage. For example, banana we can grow till the bunch comes out without any potash. Because but the moment the bunch comes out, you see the fingers, potash is the only thing it requires to bring this size. That is how it is been, fertigation plants are working. This is just a very visible example I was using, similar thing to other crops also. And of course, we only maintain the field capacity by daily drip irrigation and makes the plants healthy, increase in productivity 40 to 300% depending on crop, 300% in sugarcane, 40% in something like wheat, maize. It reduces water consumption. Everybody knows that drip irrigation reduces water consumption. Please understand that by putting a drip irrigation in the field, it doesn't reduce unless you operate the system according to the crop water requirement estimated. For crop water, now of course you don't need to estimate it. You have real-time measurement possible. You can measure it and then apply water required for the day. Fertigation improves fertilizer use efficiency. Again, fertilizer is also same. For example, if your brinjal plant is just out, no flower has come, it's still vegetative. If you are applying potash for that, you are wasting the potash. And if it's a clay soil, the potash gets fixed. Plant doesn't need it. No. So these are the new these are not anything new ideas. It is there in somewhere in the crop physiology. But when we start working with farmers, we started using this knowledge to make recommendations. Drip irrigation enhances yield. Of course, I will talk about it. It conserves power and productivity as a result increases. because it is reducing water use, fertilizer use. Mainly, you get higher efficiency of irrigation water. The highest efficiency you get with the drip irrigation compared to flood or furrow or even sprinkler irrigation. Efficiency simply means kilograms of produce, using banana, kilograms of banana produced, or rice grain, kilograms of per unit water, maybe 1 meter cube water, 1,000 liter water. That's what productivity is. And that would be the crux of future green. We are actually going through the second green revolution, even though we don't call it, by the way, because I work with farmers all over India, and I know how, at least in India and certain countries I work, how they are progressing. We are far ahead of, by the way, you have to be proud to be an Indian these days. Nothing to do with the political again. The amount of science we use for bettering human life, including food production, is one of the highest in India now. It's not I'm saying, it's what you see around. And healthcare, all other aspects, healthcare, our transportation, all that. The amount of science using, a country becomes richest, and the golden era will come when we use science to the maximum to solve problems. And we are approaching to that. That's why I said the future green revolution. Well, you already know about a green revolution. Now we understood all these things, drip irrigation, fertigation helps and all that. But it doesn't do it alone as a pocket size thing. It does with a lot of other things you have to do. You had sometimes create small scale water resources. Professor Panisselvam was telling me about the roof water harvesting, which you have. That is actually a creation of water source. It's very important. Many places you don't get it. I know a farmer, at least several farmers in Aurangabad. They grow the best oranges which you buy. They are no longer grown in Nagpur anyway. The Indian orange, the loose skin orange. He buys water in a tank from 85 kilometers away and puts the water in a small tank and then uses the drip to irrigate his citrus plants. Amazing. You see, this man goes with his truck 85 kilometers away from his farm to bring water. And he's one of the most successful, high quality orange producer. So there are people like that. Improved HYV seed is required. We need to have improved varieties. HYV is hybrid and varieties. Then we get into the management side, improved seed bed and soil management. It's a very, very critical aspect. We tell people to plow, do at right angles, that's beyond that actually. We have to create. We have to make the farmer feel for it actually. That's what we try to do when we work in the field. Then we use the biotechnology tools, all what you hear about tissue culture, DNA injections, and I modified crops and all that. What you call genome modified crops. You create and change crop geometry. I'll talk a bit about it. Spacing, high efficiency fertilizer and pesticides. You may practice mixed cropping instead of single crop, monocrop, or intercrop, or rotation, or relay. All these systems, you're all aware of it. Improving post-harvest practice, also I'll touch upon that. All this, when it is done along with the technology of drip and fertigation, then it gives you higher productivity and quality. And that is then only one can say, oh, that farmer is benefiting, or this group of farmers in that village is producing high amounts or high yields, not only high yields, with higher quality and earning higher incomes. So I call it the concomitant changes along with the main thing was the irrigation change happened. Along with that, a lot of these changes have to be packaged, and new cultivation packages are to be developed to get it. And that's been, I'm very happy to say that's the work I've been doing last 27 years after joining Jain Irrigation. I was preparing for that probably during my research years in the International Institute and all that. And feel very happy about that. Now I'm just going to give you models. Drip irrigation also is actually, there are several models. One is a simple model, pumping from a well, filtering it and injecting fertilizer, the one on the left side. And here the difference between these two models are that you don't need a diesel, you are using solar, which is also existing in many places. And then the large projects, including the line diagram, the one on the bottom right-hand side, left-hand side, okay, is that where you are not talking about individual farmers scattered here and there. You're talking about the entire villages, about 4 or 5 villages together, about 14,380 hectares. And all the farmers have got automated IoT controlled irrigation systems, and it's all centrally controlled. I'm not going into details. That's why I just put a line diagram. The water is pumped from a canal. It's gone to the pumping station. From there, it is pumped using variable frequency pumps and automated irrigation systems. No man touch, no human touch is required. It works. But the water delivery at each farmer's field is restricted. About 4 millimeter in the rainy season and 2.5 millimeter in the rain out season. That's all they get. So there it is actually 2.5 millimeter is nothing for you. 1 millimeter is 10,000 liter per acre, per hectare. So 2.5 is just 25. So if you have that much water, how can you produce a good crop of certain crops actually? So purposely sugarcane is not selected because sugarcane total requirement of 12 months is much higher. So there are certain crop changes are there. That's why the project is important. Then we have the latest IoT-based smart precision irrigation system. Very simple. All this time we are, in all others, we are using estimated crop water requirement at each stage of the crop. In IoT, we measure the actual, I'll show you one more picture later. Actual soil water measurement is done. That is communicated to the automated system and it delivers the water to bring back the original soil water content. This is the latest technology available. All of them are now getting practiced. It's not only theoretically, it is now actually practiced by farmers. Now that I thought you may be interested, you will see that in the tea garden there are two locations where the sensors are put, and the sensors are given with a small solar panel controlled sense system. From there, the communication goes to the control room where the system and the pump, everything is written, and then the pump is ordered. I just explained that to you, like in an odometer you see in your scooter. This is the soil moisture. When we are actually measuring this, what happened was the previous day it rained. So you don't need any irrigation. The soil moisture, it is been timed that the moment it reaches here, the pump will come on. And the moment it reaches here, the pump will shut off. Okay. In our case, what happened because of previous day rain, when you measuring, there is excess moisture. But this explains to you the theory of that. That is what has been latest IoT based. Now, a lot of growers are using the IoT based systems. And along with that, now we are also introducing root sensors, which actually will measure the water content or water potential in those people who are exposed to water relations of the system close to the root system, the soil water potential close to the root system, so that you can be more efficient in that. So that's how the technology works. Main thing is that we need to create in the sense that store water or conserve water. So watersheds or even rainwater harvesting sectors or water can be brought from other places and carried. This is important. Without this, in many places in central India, for example, or states like Rajasthan, etc., there is no irrigation possible. Forget about drip irrigation, no irrigation possible. So this is very important. That's also part of our work. And then, of course, the solar systems, huge solar systems. This is in Rajasthan, as I was saying. They call this structure as the local word called a DIGI. Simply a subsurface or semi-surface water tank, where water has to be brought from other places and kept it. Or you have, the smallest you can have is that we have syntax tank and store water, but the water shortage is there. And then, so this is how that part is taken care of. Irrigation water, creation of water source. So we have the applications of micro irrigation, declining water resources we already saw. And we also have another thing, acute power shortage. That's where the solar things comes in. Solutions are microirrigation that conserves water and power while improving productivity. And the result is you have to create innovative crop cultivation packages. That's what I'm going to speak mainly. As I already mentioned, if you don't have fertigation, drip irrigation alone can change the yields because the soil moisture, like a peeling line, is maintained at a steady state in drip. So the crops doesn't undergo high water and very low water or dry. That cyclic changes. The cyclic changes when it happens, physiologically speaking, the crop stops growth. It survives when the dry water or the high water waterlogging, low water is the drought. In both occasions, that is the points where it is shown here, here, and there in the blue line. These times when the water percentages are that, crop stops growing. You can measure it. Many places you can measure right in Polaki, where they are using flooding coconut basins. If you can measure any one of the growth parameters, after flooding the basin, measure for next 3 days, you will see the coconut just standing, it's not growing. The other people have done this measurement. This, especially for coconut, the French Institute for Coconut Research, I cannot spell the French word for that. They have done that study. It just stops growing. We have done it. I have done it for beans and vegetables. You excess water, you keep it. The plant will be green and standing, but no growth. And that is what is removed. That no growth period is totally removed by drip. So you get uniform growth. And you get the highest yield in this case. Here, irrigation is actually less than the optimum. Here, it is less than the requirement. Of course, it's dry. Even the potential will go down. This is actually studied under one of the US universities. One of the rare studies. And if you have excess water, many people think that many of the farmers also have thinking like that. More water, more yield. It doesn't happen. See that best water is almost 17.8 tons per acre. That's why you will see flooding with drip. It doesn't give him the water because they give only 8 hours or they give only 6 hours. So he doesn't go to the field. But the government has a more responsibility. More people have to be served. So they switch off the power. Now let us look crop-wise challenges, changes we have made, crop-specific changes. The first one we made was long back, onion. You will see a lot of agronomic factors in this. This is the way in Maharashtra onion used to be planted. Look at the real onion field. So when I went there, I started measuring the land occupied by the onion plants and the land occupied by the water channels. 33 or 32 point something percentage is occupied by onion plants. The rest of the land is used for the mud as well as the water flow. That type of agriculture. It's not only water being waste, land, it's an asset. Land is a major resources. Many people don't even have that. They toil, they work hard on somebody else's land. So this way you get about 5 tons or 6 tons per acre. You realize that why drip irrigation helped in that is I want to effectively change this method of wasting land for water. So we did this. It's about 66,000 plants. This is 2.35 lakh plants per acre. Only one drip line. Certain cases, 2 drip lines. This is a clay soil, so shallow black clay soil, vertical. So it is 1 drip line is enough. Water will spread. And the plants are 10 centimeter, 10 centimeter, 10 centimeter square on bottom. This gives 17 tons of onion when managed with fertigation and all that. So there are many changes here. One, irrigation method is changed, obviously. Second, land management is changed. It's a bed and furrow. Third, crop spacing is changed. There are only 2 rows here. 1 row here and 1 row the other top. Now, this is of course, when you go to Balaji, you see many farmers using this method. This is several years back story I'm talking about. So we realized that you can make change by sheer change in agronomy. Many of the agronomy changes are not costly. You don't have to spend money on this. Please understand, if before this farmer started this, had gone there, I would have asked him to do this. He will not do it because who am I? I had to prove the technology first, right? And we have data. So he carried that in a nearby, in the same district, in the same village, we could get this. So that's the type of change in agronomy which I'm talking about. Okay, more seeds are required. More seeds are required. You have to either use an onion seed planter or you need more labor to plant this. But it is still worth it. For a fraction of the water used here, you are getting more than double the yield. So all the rest is the economics goes perfect. That is what the key point I was trying to tell you in this lecture. So that these type of changes are now happening, have been happening for many crops. What are the changes? Okay, there are other changes also. We supplied good seed for the farmer. Elite seeds were produced. Planting method, you saw it already changed. 10 by 10 centimeter. Crop geometry changed. Fertigation. And of course, agronomy advice have to be given. Farmers will have several questions. He will not just take it like that. He has to be shown what are the benefits. Understand that. This is a pest management. Actually, there are lesser problem because there's no standing water. But still, there are bolting. Bolting is the stem will grow, so you don't get the bud. All that will occur. Then we also started teaching about field curing onions. Just don't bring it to the, they will, And onion has to be stored in well ventilated, aerated space, not in closed rooms or in. Onion should never be kept in the refrigerator. I hope you all know. Many of the people at home also know. Onion, pineapple, and banana. 3 things and garlic, of course. Leaves. They should not be kept in the fridge. Many people do banana, and the second day you take it, the skin will be watery and black, and then blame the supplier, the poor fellow who sold you the banana. He didn't ask you to keep it. He will ask on his roof. He will hang. That is why we are hanging the banana bunch in the front of the house or the back of the house. Should not be. Like so is pineapple. Some of the common things. And in our case, we had trained a lot of young agronomists and put them in. Because we have we are buying back these onions and processing it also. Now we have the challenge. I already mentioned that. That's the difference. Before technology invention, you get about 6 tons. In the very good ones, you get about 16. And then we are producing only. Otherwise, you get a range 9 to 16. See, but there is another thing which you learn in extension. If anybody is interested now, practicing. In extension, if you tell the farmer 10 things to change, he will change only the ones convenient to him, which may be 3. Okay, so he takes 3 steps. So we keep on working with the farmer. It may take about 7 to 10 years. So he will change all the 10 things which you are telling. That's why agriculture extension is very difficult to implement. Teaching is easy. Teaching in a classroom. But practically doing it in the farmers is difficult. So like that, when you do that, you get high. Some farmers will listen and do everything for you. The average, your average is higher than. So this is how drip irrigation when it is. Now, in this case, what I'm trying to tell you, the drip irrigation is a catalyst only. It's just a technology. You use your ideas to change and get the maximum benefit from the drip irrigation technology. Farmers will be happy. That is how the technology picked up. Now, it also increased the solid content, the TSS, the onion that's and the sodium details, and the yield. Okay, we were working 1996 and 2011, etc. Yeah, I'm doing. So, what are the scientific disciplines, just for the sake of discussion? Horticulture, of course, plant breeding, because new seeds were introduced. Tissue culture science, then later bulbs we are producing it. Plant pathology, you are advising on the disease management, biochemistry. seed protection technology, agronomy, and of course post-harvest technology. All these are in that. All this is to be done by. I'm sorry, I'm having a bit of trouble with the. Another one I can talk, which is close to you, is the mango story, which we developed technology. It is also there in your TNAU. Dr. Vadivel, he was the dean. He requested us, so he took the technology and put it in your website. We developed over a period of, anyway. Basically, the problem with the mango was a long gestation period. You plant a tree, after 15 years, you get 7 mangoes. That is not agriculture or even horticulture. That's waste of time. Waste of land, waste of resources, waste of farmer time. We need something which should be generating incomes fast. So we tried on ultra high density with canopy management as a technology to apply, and later it was studied also. Dr. Balmohan had 2 students working with us on the canopy management. So it goes on. Fruiting happens in 3rd year. Very good. When bankers were attracted to this project now, because they cannot give you money to plant a mango and wait for 15 years. No bank will invest. Now they will. And you get alternate bearing can be converted to regular bearing. Every year you get fruits. And of course, very high yields. I'll show you some of the data. Amazing yields. This is the part of the training which we established for the branching system, the canopy architecture. And that's this flowering occurred at 2 year, 11 months time. So the mango flowered profusely. Then we knew that we are solved a problem. Now here, again, I've just taken 2 examples. When do you want to irrigate mango? Not when do you want to. When does mango want? Mango wants water. In Tamil Nadu, for example, this is the irrigation period required. You can read that. Because you have the northeast monsoon. I just compared with Chhattisgarh. This is the southwest monsoon. So you have it. This has to be understood very well where you are doing mango. Not that when you have water, the tree is irrigated. When you don't have it, you don't irrigate. And the tree requires a dry period. Very important, a dry period. Yeah. You should not irrigate. Even if you have water, even if you have nutrition. Because you have to give a kick at the back of the mango trees to change the vegetative mitosis happening in the tip to flower buds. When you are deep into that, you can study all this. Simply understand the vegetative bud has to be converted into flower buds to get flowering. The flowering happens. So irrigation, control of irrigation is very, very critical. That's the point. We have a method for control of irrigation. You can switch on and switch off when you want it. But using the knowledge for the mango is what the agronomy required. Now, this is the example, liter per day per plant for a place like Endowment, where we first studied this. You can see the evaporation, based on evaporation. Sir, you see this 4.6 in my original. Yeah, it was, as I said, everything I write, I use 4 fingers and type my own. So one decimal just went off. Similarly, fertigation schedule. Here again, the idea of fertigation is not dividing the fertilizer into many types. The idea of fertilization, when does mango want phosphate? And when do mango trees expect potassium to be available so that they can take it? Now you can see that it's there. That knowledge is what we are using. This knowledge is available even in classic agronomy, but applying that is more important. Now, another thing with mango was to do canopy. You see the gentleman's name here who worked with us. All of you are familiar with Endowment, and his student is Goku. We have published all that. Canopy control, that's what is the research team. We were studying the severity of pruning. All the mangoes, trees have to be pruned immediately after harvest. The harvest happens in April, May time. So June is the right time in Tamil Nadu. because you don't get rain at that time. You had pruned the tree back, not only keeping the size, keeping the younginess of the crop, of the tree. So when you see our tree, which is now 18-year-old and 17-year-old, the base part of the tree is 17 and 18-year-old. But the bud or the stage where which the flower comes is only 1 year old. So that's the science. 1 year old at least is ready for giving. So the tree can age maybe at the base because the secondary hardening happens, soil employer multiplication and all that. So that's what it is. So to do that, you have to do the pruning at the proper time. There are a lot of science, so we have done it. And finally we are at conclusion. So I'm not going into details. So pruning is actually a scientific thing, actually, not cutting down branches or reducing when you feel like. You see, third year, we got 9 tons per acre in the fourth year. Low gestation period is achieved already. This is actually on the, it's not even 10 year, at that time it was 2 years and 11 months. That was. This is what the Totapuri variety. We had to record yield. 25 tons per hectare. I'm not saying big things. This is a world record. When we harvested 25 tons per hectare, that's the highest yield in mango ever harvested in the world. Okay, it happened. Now we have proved that. You can see how the yield developed. Alfonso is a shy bearer. It cannot give you 25 tons, never. So it gets, you know what, the shy and the profuse bearing. You have the female flower to male flower ratio. And I don't have time to go into those scientific details. You started with about 3.3, and then you reached about 9.75. It fluctuates. But you take Totapuri, we started in 2013 only, when this technology started in 2009. 2006 planted, 2006 you have 26 capacity. You will see why I said it is the high field. In India, before this technology was there, India was this is the National Horticulture Board data, NSB. There are other countries, Indonesia, what other countries here? Thailand, even Pakistan. They are very good in certain things. And Brazil, the highest field. So we could achieve much beyond that. That's why I was saying that. So India remained at 6 tons for a long number of years because we only planted 40 trees in an acre, and we expected the tree to do. We might have irrigated the trees. We might have applied some organic manure to the trees and waited. And the tree grew, and it grew, and it grew. It became like a big banyan tree, hardly producing 200 or 280 mangoes. I have counted a lot of the larger trees. How many mangoes a tree produces? Certain varieties. This is the way technology actually works. What are the changes we made? That's what you had to look at. Agronomy. We did softwood grafting, which is not our softwood grafting was available, but we used only softwood grafting in nursery for the new plants. We changed the crop geometry, 3 meter by 2 meter. In other words, 674 trees per acre. Originally, there used to be only 40 trees per acre. We changed the training. Training you saw in the 3 plant-led side showed you the tip removal and the grant. Cannot be managed by pruning, of course, drip fertigation, mulching, and post-harvest management. So these are the agronomy changes made in that. Of course, banana, many of you would know. I'm coming to next crop. We started looking at yield as for many, you get a 13, 14 kilograms per bunch, very low yielding change. So first change we made was a tissue culture, and it becomes now the largest tissue culture producer. Micropropagation, I'm not details. This is the stage it goes to the farmers. whether it is brand name or Nendran or Tengadali or several varieties are there, Katpuravalli. We change introduction of tissue culture. It actually gives you virus-free plants, more important. From geometry change, start planting closer. Either 6 feet by 6 feet or 5 by 6 feet, depending on the soil. Then bunch management, covering the bunch, etc. Platoon management to get if one is planted, next 2 years, so 1 plus 2, 3 bunches you can harvest from one. Don't take me literally. One banana will give only 1 bunch, but you are using one of the sucker, which is right there without cutting it, and then making it the second bunch. Like that, 3 years you can get by. Now we are using RNAi to include disease resistance. It will come. Now this is what the technology is. This is you may know familiar in banana most developed place. The 2 places, one is Delhi, the other is Sirubuki. This is the way it is planted with the drip irrigation and this any type of soil. And sometimes we ask them to add technologies on top of that mulching. The Nana mulch. So that is not only at the young stage, you see even at the mature stage. If you don't know, many of you can predict the yield of banana by measuring the girth. It's a direct function. So right from the 2 months old banana plant, if I see it, I'm not going to predict the exact number kg of bunch, but I can tell whether the farmer is going to get higher yield or not. So the bunch, this is where it's growing, it will grow. So we measure the diameter of that and keep a record of it. Now we have taught that to many farmers, they know it. So if there is any problem here, blood development, we can make correction in fertigation. The correction has to be made with, because we cannot expect 12 months to wait and get a small bunch. The farmer will kill you because he has spent money to buy all this. So you have to make corrections bunch. So this is a monitor character. Monitor about 1 foot above the ground. You measure with the tape. And this is the uniform bunches. And some special cases in North India, especially and Central India also, during planting time, monsoon comes only in Kerala on June 1, by the way. It doesn't come there also now. It comes late. People already start planting. So it would be, this may be in Madhya Pradesh, North Madhya Pradesh or Rajasthan, to be give a cover. There is a technology to keep from the initial leaves will be a high temperature will kill them. So to protect, there are ways doing that. I'm just putting different technologies actually. So all this will go, but you don't need all the technologies everywhere. For example, Delhi, you don't have to do that. Because Delhi is generally cooler than the rest of the Tamil Nadu. And you don't need cooling. By the way, this is one of the technology has made many farmers super rich. And in Maharashtra, farmers' son, let's say sons, from banana income, they have gone to University of Harvard and got PhDs, engineering. They are scientists now. Imagine a banana income. And so we are very happy about that. Actually, in Karnataka also, not Karnataka. Otherwise, those boys and girls, they will never see a good university in their life. Unless the father, change the total technology of growing banana. That's sort of bunches we get it. This is only up to 2030, but now it is far higher. So we say that in another 15 years, any banana you eat in India, anywhere, will be produced by a tissue culture plant from our side. That's the aim. It will happen. Now it's happened for me. This is what racooning is. You see, the mother plant, just for sake of mother plant is harvested. You should never harvest this because I have done measurements on this. Almost 38% of potassium required for this daughter is here. So it will die on its own and incorporate into the soil. Many places you will see banana cut and brought to the roadside and they just leave it there. And some people do business with that. They will, banana fiber, they use it for, okay, but that's very rare. But most of the cases it is wasted. And it has got more potassium especially, and then phosphate and other minerals, so that it will become. And this daughter is amniotically connected with the mother. You understand what I'm saying? So it is not a separate plant, so it gets it. That's how the tuning is done. Of course, we taught farmers about the post-harvest technology. I'm not going to take much time. Banana should never be harvested as a bunch. It should be harvested as hands. Hand. Each one is hand. And you can still see banana bunches put together and the tied with the tarpaulin and taking into the market. At least all the fruits on the periphery will be damaged by that. Easy plants, crop geometry, mulching, drip irrigation, IPM, integrated pest management, food bunch management, post-harvest. All are the interventions we've done. Pomegranate, I'm going to do quick now. I know your time is, my time is up. One of the major problem with pomegranate is to be bacterial blight. And it used to spread, by the way, pomegranate is not a very popular crop in TNAU. I know it. Dr. Kumar told me, tell me that. Because there was a time even in your syllabus it wasn't there. Later is added. But anyway, now it is grown in places. Bacterial blight comes because only booty is the horticulture people will understand what booty is. You extend one branch, put wet soil around it, tie it with plastic, it will root, cut it and plant it. Along with that, you are actually transporting the bacteria. That is why pomegranate, it used to be good in Bijapur, North Karnataka, and Sholapur, southern Maharashtra and all that. It was wiped out because the bacterial blight. I'll show you next. What is that's the bacterial blight. This fruit has nobody will buy it, even if you go to market, anybody. Now, this is the fruit. With the tissue culture, you don't have the bacteria issue at all. That was the challenge there. What is the causing the farmer not to grow or to make losses? We understood that. So we had to have a solution. Okay, along with that, there is spacing, crop geometry, fertigation, irrigation, everything is there. But the main thing is that. This is free plants. This is why the pomegranate tissue culture plants. Tissue culture, crop geometry again. We changed the crop geometry, by the way, the planting pattern. Fertigation, bar treatments. For your information, the sand dunes of Rajasthan, nothing used to grow. Sand dunes of Rajasthan for lack of water, high temperature, and the wind shift of the sand. From one, you will see a heap of sand today morning. By evening, if you mark that as your landmark for your walking, by evening when you come, there's no sand dune there. Because sand is shifted to somewhere else. Because of that, nothing used to be grown there. Now, all these places are now stabilized. They are growing with the pomegranate, the most successful growth. Okay, now coming back to agriculture. Irrigation, sugarcane is one of my favorite crops. A lot of work has been done. Flow irrigation like that, and drip, surface, drip, subsurface. Here, a lot of work has been done to adapt to drip. People used to originally love it. There are very strong soil type. You can see the light soil, medium soil, heavy soil are taken. The dripper to dripper, because in agriculture, in free crops, the spacing of the tree itself is the drip line spacing. In agriculture crops, not like that. So you should know where to put the drip line. Whether you have one row of the agriculture sugarcane and a drip line or two rows, all depends upon the soil. That's what so a lot of study has done in that, and now we have standardized. This is, for example, the surface drip, one drip line. In average, you can have two lines of subsurface, same thing. So the spacing is changed. When you change the spacing, population changes. Number of stems changes. Number of tillers changes. And number of tillers makes the millable cane. When the millable cane changes, yield changes. Just to, and also even this, the drip line requirement. When you have one drip line, two rows, you are cutting down the drip line requirement to half. So you get a lesser costly system for farmer. Then later we found that I was doing all this agronomy with several sugar mills in Tamil Nadu, Maharashtra, Karnataka, Andhra Pradesh, Telangana, and all that, Odisha. Then suddenly this villain came. This villain is the machine they use for cutting cane. Its blades are fixed. So then we started working with the machine people. Mainly there are case, it is a store, it's a German machine and New Holland machine. There, the space between two blades, cutting blades is either 4, 4.5, 5 feet, 5.5, 6 feet. Later, this is the deciding factor on the crop agronomy, the spacing. And then drip irrigation has to be changed to accommodate this space. So you can have, sometimes you get an external factor coming into your thing. This has happened something around 2005, 2006. That's where the machines, especially in Tamil Nadu, the sugar mill started buying the huge machines for harvesting. Because Orissa and Bihar labor, more of them become IT graduates and started working with computer. They didn't come to Tamil Nadu for cutting cane. It's actual fact. It changes. Here it is. You have one drip line, two. This is subsurface, that is surface. You can see here. In the subsurface also, only that much is wetted. This is pure dry soil. Why do you wait here? There are no roots here. Later, when and this is the way it is installed. Below the ground, two sets in the middle. You see cane, excellent cane. You do fertigation also. A lot of work is done on fertigation too, changing the agronomy. Then I took this technology to another largest sugarcane country is not India. India is second largest. 4.8 million hectare. Is Brazil. Brazil is the largest, 10.5 million hectare. So and they were accorded me with royal welcome. Just because we worked with one sugar mill, because they were, see, you can talk any number of times, nobody will take the technology, you have to prove it. So we did 3 locations, 50 hectare each. And we dug out and showed them, this is the drip line below the ground. This is a large installation. And this is 3,000 hectare. And here IoT is practiced. Because here, if you do, imagine 3,000 hectares, a huge land. So crop water estimations can go wrong if you do only based on evaporation. So we introduced sensors, and sensors are then will come to this controller here, and then they decide based on our program we put in the irrigation time. So the irrigation and fertigation times you can see where I'm standing. These are the fertilizers, huge ones. So you have to feed it. Highly automated. And now we have done several of them. I don't have to go anymore, not because of COVID. We have trained people there now. That is the one country benefited with this technology package to the maximum. Wheat is grown with the drip irrigation for you. I did it about 12 years back. And I also worked with the Wheat Research Institute in Karnal, Haryana. They were happy about that. Otherwise, it used to be wheat means 4 irrigation. That is how if you look at the books on wheat, 4 irrigation. They won't say how much, when, all this. It's all changed now. A lot of people now we are doing actually rice wheat rotation. You know, in Kharif means June, July, August season, they grow rice. And in the October, November, December season, now they grow wheat. So and all the irrigation is drip irrigated and fertigated. Excellent crops. Pigeon pea. So another thing. When pigeon pea was drip irrigated and I produced 1.5 tons per acre. A lot of people, including the pigeon pea researchers, said how is possible. We didn't do anything. We changed agronomy. We changed the planting pattern. And introduced irrigation, drip irrigation. And but you need to irrigate very little to work pigeon pea because its roots, one of the deepest roots of any agriculture plant is pigeon peas actually. Goes up many places, including Nicholson, when I was working there. You can get, even after 3 meters, you will see pigeon pea roots sitting there. Which has that ability. That ability we made use of it. Chickpea is another crop. That is Bengal crop. So these 2 crops are now, this is called the large project we did in Karnataka. Where we totally changed. It used to be only 1 row of chickpea around here. That's how farmers used to grow. And they never irrigated. it's a residual moisture crop. Residual moisture means whatever rain left in the soil will be taken. So the yield will be about 400 kilograms, 250 kilograms. It's not changed now. It's very high yields. We change the pattern of planting also. The 2 rows now. This is the most interesting thing I ever did. This is in Kashmir, Shalimar, University of Shalimar. When we were doing a lot of fruits, the scientists contacted us and said, can we do something for apple? Okay, apple used to be planted, one apple there, another apple here, and then you can run a truck in between. I used to ask them, what is this land here? So we changed it. See the rows here? We just planted, you can see apple plants. Now, it was very difficult. With all apologies to scientists and qualified people, let me tell you. To me, working with farmers is easiest. Working with scientists is very tough. Because scientists sometimes think in the most unusual way. Farmers do not. Farmers always think straightforward. What is he saying? You get more apples. You get more mango. Very happy. So here, I got old by convincing. It took about 2 or 3 years after planning what to do and all that. And in the winter, that is the place. Same crop. In the winter, if you go now, it's all all leaf. Apple will shed its leaves, which is required towards a particular freezing temperature. They don't need flowers. And now in the summer you get fruits. It worked very well. Just at the start of the flowering season. See? Totally. 18 times more plants are there. 18 times from the conventional. So this is an interesting study. But now those scientists we are friends anyway. I never had a different opinion with them. It took a lot of time in talking and making them. Then of course after we did the planting and all that, they start following the irrigation schedule, and we left them. Now the technology is saffron. Another one again in Kashmir, only in Kashmir growth. Himachal also probably grows. It used to be like this, random hills. People who are familiar with the yam and chene, the saffron tuber will corn, it's a corn. They cut it into pieces and then plant it. So that's what it is. And in the winter it will rise below the ground and then it sprouts. Irrigating this will be a tough job. Either by pot or by hose. And this is just to make sure. So we first tried with the micro sprinkler, then we did. First time it is now in rows. Saffron is in rows. It is drip line. So again, the number of, saffron is very special. If you want to become a millionaire by 1 year, go to Kashmir and grow saffron. Because saffron is the most precious crop. The competitor for us is Iran. Iran grows. I call it the saffron. So this is either single row or 1, 2, 3, 4, 5 rows on a bed. So this is where please understand that's an agronomy change happened from that stage to this stage. You get more flowers, of course. You get more flowers. You get tissue culture lands, and of course we are also working with them with the university on tissue culture saffron production because the corm can carry diseases which are the previous season. You cut it just like a cheddar. You cut it into pieces and then bury it. Land surface management, the bed and furrow and all that, crop geometry change, which you saw. Maize. Maize is an amazing thing, but the Indian maize which we use will have only 1 or 2 crops. So population design. This is where the farmer originally, when we gave irrigation, used to do only 2 rows. And I found out 33,000 plants per acre. Maximum can give only about 60,000 pots. So there's a limitation in yield. You have to do something. So we changed into 3 rows. And 1 more row is added in the center, slightly pushing it down. And we still gave. So now we have 44,000 plants per acre. So 1 change made to get. Otherwise, it's impossible to increase yield of maize. You will be spending more. Spending with you are putting irrigation systems. So that's one case. Okay. Rice, of course, I don't want to go more detail. We have started in 2007 and we did different things. We did even mulching there. You can see, and you can produce. And one of your ex-colleague, Dr. Sundar Singh, many of you know, he retired from here as a registrar. He was with us. So he helped in all the field work, and of course we have published it all. Now I've been with this for last several years, looking for now more of this technology has been adopted by basmati growers in Haryana and Punjab. This is the major change. Normally, when you control irrigation, you will use 9.5 million liters of water per acre for the entire season of rice. It's about 100 days or 105 days. It's a lot of water. You cut down that to 3.2. You see the difference? 3.2 million. And still, this gives you about 20% more yield. Of course, with the fertigation. And so that's the beauty of the technology. But this technology is not going further as much as we expected, like in maize or in apple or in other crops like pomegranate, banana, and all that, because mental block. People still believe, except a minority of people who are actually practicing, that it has to stand in water. By the way, rice is not a hydrophyte, for your information. Hydrophytes are plants which grow in the standing water. Rice is not like that. We made, not we, long back Chinese made it. The history of rice, if you study that, you will see that. When there was no irrigation those days, rainwater used to be the only source. So what then if I have a land of this whole size, I will immediately put bunds there, here, and there, so that this water will be impounded with that and plant rice. So when you look at rice, you see always water standing. Because the moment this water is let out, my neighbor will get the water. I want to. He's also doing the similar thing in this land. So that was the lookout among the Chinese farmers those days when there was nobody even thought about irrigation technology. The word irrigation itself was not there, I think. So that is where that thought process is still active. That's the major difficulty. The other is the investment. There is an investment here. In rice, people want to invest the least, harvest best. That is the policy in rice cultivation, even now. Everywhere. So that also is another factor. Slowly it will come. Interestingly, I have farmers I'm not saying as a pompous thing, in California who use this technology to produce basmati. Basmati, we are not the only one producing. Other countries also produce. And they found it's very useful because they look at the total economics and they found this is the best way to do it. And Spain, limited. All these are countries which are not known for rice growing. USA is at least better known. But they found that it's a good technology. Many people are actually trying to adopt, but not so happily adopted in India. It's an actual fact, actually. This is the reason. In the flood irrigation, you are getting about 0.1 kg, which is 100 gram. About 100 gram grain per meter cube water. This is water productivity. 1 meter cube is, all of you know, agronomy, it is 1,000 liters. There is a method called SRI, which originated in the university, one of the US universities. There they try to spread it to many places, but there are other issues. It went up to about 480. In drip, we still get up to 580 grams of rice per 1,000. So its water economy is good. All right, administrators understand this. Farmers have not fully accepted it. That's the reality. We have to work hard. Now, what are the interventions? Flat beds and land surface management is introduced. Flat or beds. Water management through drip, soil physics, soil management, and addition of organic carbon is very important. Most of the rice fields are cultivated repeatedly, and you will see organic carbon is less than 0.1%. You need 1% actually to get decent production. So you have to keep on adding. Of course, micro and water management. Now, basically what happens is these are all precision farming. And in our case, generally, we work with about 3.8 million small farmers with the different technologies, different crops. And we are still working with many That's our mission. It's not only for crops, we do research in plastics. I just want to touch up just one case. We try to develop a dripper, which is already there in the market. Doesn't clog. I don't want to go more into this is our own research, it is patented product. So a lot of research goes on that. There you look at hydraulics, product design, mold, polymer engineering and all that. This is the overall summary of whatever for all these crops. One change or the other is introduced through drip irrigation, fertigation practice, and you are getting a BC ratio for rice, one of the lowest, 1.6. What it means, if you are not in economics background, economics will observe it. If you invest 1 rupee, invest in the rice crop, you get 1 rupee 60 paise back. So you get a 60 paise per rupee profit. That's it. For example, if you're doing papaya or mango, you get very high. For 1 rupee gives you returns to 4 rupees, 5 rupees. So this is how economists assess the value of the technology. That's what I'm showing. I work personally with about 63 plus crops. Every time there is some challenge. Actually, now I'm working on avocados and rambutans and all. It's very rare, but it's now getting more common. Working in getting technology packages. And you can see that it covers most of the Indian states. What is more important is, it is not a drip and fertigation alone. All these crops, one thing or another, agronomy is changed, either in crop spacing or in the land management or overall crop management, different things as I gave you in the detailed examples. That's how it is made possible. This is, of course, the way we work. We also do a lot of research, by the way. That's why I'm standing here. Research, and we do our own research as well as we do with the collaboration with the universities and international institutions. For example, this is the rice research. We collaborate with many universities, including yours. That's where these doctoral and master's students are getting support. And we do a lot of training. This training is for farmers, basically, on mangoes. Not only in India, other countries like sugarcane in Ethiopia, vegetables in Kenya. And you should understand those countries, you have a beautiful hall. When I was commenting on that. When you want to do a training for farmers in Kenya, you will get only a tree. All the rest, I had a van there. So this is the board for writing. Because you cannot do online, offline slide projection there. So you have to draw everything. These are the farmers. And in African countries, when you work, you will see any farmer meeting will have almost 70% ladies. Women are more farmers and the rest men. This is how we actually go into the one more. See, look at this. This is our agronomist who works with me. This is the trellis of a cucumber crop. Yeah. Now, what he's trying to explain to the farmer is, why are you leaving this much space? Why don't you have one more? That's what exactly is. One more row. You get more cucumbers. That's exactly the idea of agronomy coming in and increasing productivity. Why this is not possible here? This is watermelon. Why? This is the space required for the watermelon to spread. It spreads to here, it spreads to here. It's a spreading rule. So you cannot apply same principle everywhere. It should be crop specific. That's why I just selected this. And we have changed many places where the trellis crops are, especially in Andhra Pradesh, Telangana, and of course in Tamil Nadu. You can have double the production just by increasing plant population. Because of students, I am just throwing out these ideas. That's how one should look at when we go to the farmers. I'm not saying that they are doing mistakes. It's there in over the years. Grandfather, great-grandfather is telling them, if you are doing cucumber, there should be only 50 rows of cucumber in 100 meter. one side of the land. Because that's the way they did. I'm going to tell them, no, you should have 100 per meter, 100 or maybe 150. So that change is what is going to make the, that's exactly what is happening. In the process, you can have a better variety of cucumber, more suitable, more fruiting type. No, this is more vegetative type actually. More leaves, less fruits, less flowers. That also can be done. This is the Bolt's idea of guidance. I like this, what Albert Einstein said. If we knew what it was we were doing, we wouldn't be doing. That is not research. Thank you.
The time for interaction.
Sir, because you had said about that growth and yield in banana, isn't it? Can you give us what is the procedure that you follow if it is not?
No, it's not secret.
Okay.
I'm the number of farmers and educating them. No, not at all.
Relationship between the growth and
Yeah.
yield.
See, now let me ask you a question. It's better I get the. Yes. Do you know after planting a banana sucker or a tissue cutter plant, when does the bunch form inside? When does the bunch, which you will see only after 9 months or 10 months in the banana,